Hello, my name is Ethan. Today I'm going to talk about a friction force with Felix and Zero. Let's begin. First of all, what do you think is a friction force? Well, it's a force which applies between two different surfaces, and it always works in the opposite direction of the movement of object. For example, if the object moves this direction, the friction will apply in this direction. Well, then, what are the advantages of having friction forces? Um, it might be helpful if you can think about your own experience. First of all, uh, walk and drive, walking and driving. We can walk and drive thanks to friction forces. Without friction force, we might slipper on the floors. And also, um, on the other hand, skating is some other activities that we use by reducing the friction forces. And next, now let me explain about friction force in more scientific way. Friction force is can we can say friction force is like this: F equals to mu times n, where mu is a coefficient of friction, and also n is a normal force. I will explain more details on coefficient of friction in next slide. In this slide, let me explain a bit about like normal force, since you have to understand what is normal force to understand friction force. Well, normal force is a force which applies on the surfaces where the object stays. So, uh, for example, in this kind of example, if the object is on the flat surface, its normal force will be equal to its weight. All right. Let me tell you more about a coefficient of friction. Well, technically, it is a ratio of between friction force and normal force, like this. To make it simple, well, it's a constant that that tells you how it is easy to move the object. Well, so if the coefficient is like bigger, then it means that object might be really difficult to move. On the other hand, if the coefficient is smaller, it means it's quite easy to move the object. Well, I will give you some more specific example like this. Well, since the coefficient of friction is a property of some materials, as you can see from this table, um, shoes and wood and shoes and ice, the coefficient of friction of shoes and wood is 0.9, and the that of shoes and ice is 0.1, which means shoes and wood, it has more friction force than shoes and ice. Well, let me explain about a static and kinetic friction force. In terms of friction force, there are two different types of friction force. One is static, and the other is kinetic friction force. The differences of two friction forces are, well, as you can see from the name, it's one is like static, which means like if two different objects are not moving, then the static friction force will apply. On the other hand, if the objects are moving, then kinetic friction force will apply. Basically, its formula is same, like F equals to the coefficient of friction multiplied by the normal force. But here, the coefficient of static friction force, and here the coefficient of kinetic friction force will work. Well, and here is a plot that compares two different forces. One is static friction force and the other is kinetic friction force. Well, actually, this black vertical line is a point that the object starts to move. So this is quite important in here, in this plot. So until that point, the static friction force will apply. The interesting thing is that it will increase by this amount. However, once the object starts to move, then kinetic friction force will apply. But as you can see, the friction force will drop by this amount, which means the highest point of static friction force is always smaller or equal to kinetic friction force, like this. Well, analyzing of this plot is, you guys might have some very common experience of when you try to move something, like really heavy thing, it is really difficult to make it move, really. But once the object starts to move, then, well, you don't really have to put like same amount of force to move the object. Well, so far we have seen about like the friction force. From now on, the Felix will talk about its experiment of this. Right, Felix.
Hi, I'm Felix. Then I will talk about some experiments about the friction. First, if we put something with 100 grams, like a rubber, then we want to make it move, what will happen? Let we see. We can see the force was more bigger and then more smaller, like this. We can have the force and the time graph. What happened at here is kind of like Ethan just talked about is static for friction and the kinetic friction. We know if we want some things move, we need more force to make it bigger than the static friction. And then if we want to make this rubber keep the same speed, and then we need to make the force equals to the static friction, then we can get this. And we can see if we have 100 grams and the rubber on the concrete, we can get the force is like bigger than 0.5, smaller than 1/4. But if we make the weight like 200 grams, then we make it move, we can get the graph changed, and we can get the force to make it on the same speed to move. It will become bigger than 10 force, smaller than 15 force. Why it happened? We all know that Ethan talks about F equals mu and N. N is the normal force. It's about the things weight. So we change the weight, but we not change the materials. We only change it from 100 grams to 2000 grams, and the normal force was changed. So the friction was changed. But if we change it on the F's with the same weight, we can start it, and then we will see the force and times graph. We can see it's almost only need 1.5 force. Because we change the materials, so the coefficient of the friction was changed, and then we can know if because of on the ice is more easier to move than on the concrete, so we need a more small force to make the things to move. Then Zre will talk about the friction in our normal life, we can use it to help our life.
At eastern side, the friction is existing between two surfaces. So the friction is very common in people's daily lives. And now I will introduce some applications of the friction. When people are walking, the friction between the shoes and the road make the people can move forward. And the friction is also used on the tire. This is a normal tire, and this is a snow tire. Obviously, the snow tire is rougher than the normal tire. According to the formula, the friction is μn, and mu is the coefficient of the friction. So a rougher surface will have a bigger coefficient of the friction. So the snow tire is more safely than the normal tire when the car is moving on the ice or the snow. And on the other hand, the skating is opposite to the tire because the ice is smooth and people want to get a high speed in skating. The skate athletes can move on the ice in the speed of 50 kilometers per hour. It's much faster than the running. That's all because the ice is smooth, so the friction is small. In conclusion, the friction is existing in the touched objects, and the value of the friction depends on the rough or smooth surface. I forgot. Oh, people can use this characteristic of the friction to facilitate people's daily life. That's all. Thank you.